Okay, this is section 4.4. We're going to be solving systems using inverse matrices. Um, we've solved systems of equations before. We used solving systems by graphing. We graphed two lines, and where the two lines crossed, that is the solution to that system of equations. We also solved by substitution, and we solved by linear combinations. So far, we've learned three different methods for solving systems of equations. In this section, we're going to be learning yet another way of solving systems. This time we're going to be using inverse matrices. The homework for this section is 45 through 52 in the homework packet. First thing I'm going to work on, example 1, we're going to multiply these two matrices together. Now I know the matrix on the right looks kind of funny, but we're going to multiply just like we would regular matrices. I have rows on the left and columns on the right, so I need to multiply the 2 times the x, so I have 2x, and I need to multiply the 4 times the y, 4y, and add those together. Can you combine the 2x and the 4y? Well, no, they're not like terms. So we're going to have 2x plus 4y. That's going to be the first entry. If you look at the second row, let me erase this so we get a little bit clearer picture here. The second row times this column, I have the 6 times the x, which is 6x, and I'm going to add the 3 times the y, which is 3y. Funny looking matrix, but there you have it. Now the original two matrices, the one on the left is a square 2 by 2 matrix, and the matrix on the right is a 2 by 1 matrix. Now remember, when we're multiplying matrices, the inner two numbers have to match, which they do. That's 2. If you look at the outer two numbers, we've got a 2 and a 1. What that tells us is that our answer is going to have 2 rows and 1 column, which this matrix, this answer matrix, does. Okay, this answer matrix has 2 rows, and you can think of this as being one item if I were to actually add those together. So while it looks kind of different, it does indeed actually have 1 column. And I know it's getting kind of colorful here, but the point is that this matrix is a 2 by 1, so it does satisfy what we've learned about multiplying matrices. Example 2, I'm going to have you do that yourself. I'm going to have you work on that. If you have questions, be sure to bring those questions and ask me in class. So pause the video and work on example 2. When you're finished with example 2, go ahead and start the video again. Example 3. What we want to do is write the system using matrices. This is not laid out very well. I'm going to move this over so it's a little bit easier to see. So I have negative 2x plus 6y equals 4. I just rewrote it so it looks more like a system, so that one equation is on top of the other. When I say write the system using matrices, I'm going to have 3 matrices. I'm going to have the matrix on the left, which is called the coefficient matrix. The matrix in the middle is the variable matrix, and the matrix on the right is the constant matrix. So what I'm going to do is get a bigger eraser. Okay, matrix on the left. That's the coefficients. When I say coefficients, I'm talking about these numbers that are in front of the variables. So the top equation has a coefficient of 12, and for the y, it's negative 7. Be sure you do the negative. So that is negative 7. The bottom equation, we have negative 2 in front of the x, and we've got a positive 6. Now with the 6, we don't have to write the positive. We do have to write the negative for the 7. The middle matrix is the variable matrix. So the variables that we are using are x and y, so I'm going to write x and y. The last matrix on the right is the constant matrix. The constants are these numbers right here, the ones that do not have any x's or y's. So 9, 4. When I ask you to write the system using matrices, this is what I am looking for. Example 4, I'm going to have you do that on your own, so pause the video. When you're done, I'm going to have you restart the video. Example 5, find the inverse of the coefficient matrix. To do this, I first have to find the coefficient matrix, which we know how to do. I look at the coefficients. Those are the numbers in front of the variables. In the top equation, I've got 5 and I've got 24. Be careful with the bottom equation. Remember, if there's no number in front of the variable, there is a 1. So you're going to put a 1 here and a 5 here. Now the direction said find the inverse of the coefficient matrix. We know how to find inverses. We're going to multiply these two numbers. So if you recall, we're going to find the determinant first, put the 1 on top, and then multiply. So these two numbers get multiplied for 25, and these two numbers are 24, and we subtract them. When we subtract them, we get a 1. Now with the inverse matrix, we take this one and put it in the bottom, and we put a 1 on top. It's always a 1 on top. The number on the bottom changes depending on what number is over here. Okay. I'm going to clean this up a little bit with a bigger eraser. Okay, 5, 24, 1, 5, and we have 1 over 1. Okay. The next thing we have to do is these two change positions. It's going to be hard to see, but this 5 is going to go up top to there, and this 5 is going to go down here. So my 5's changed position. As far as the 24 and the 1 go, those change signs. So the 24, instead of being positive, is going to be negative. And the 1, since it's positive, has to change signs. It's going to be negative. At this point, we're going to multiply by 1. I have 1 divided by 1 is 1. If I take the 5 and multiply by 1, well, 5 times 1 is 5. Negative 24 times 1 is negative 24. And negative 1 and 5. So the inverse of this matrix, 5, negative 24, negative 1, 5.